This is video number 3, talking about section 2 of the report on seismic waves. When an earthquake happens, energy is released from the focus as seismic waves. These waves are most powerful at the focus. They'll travel out in all directions, up towards the surface and down towards into the ground. And they will lose their energy the further out they travel. So they'll start with lots of energy, and the further they have to go, the less energy they will have. We will measure this energy on seismographs. This will give us the distance, how far away the focus was, and this helps us find the epicenter. And it will measure the magnitude, give us a number on the Richter scale to say how much energy was released. These are what the seismographs look like. So a pen runs on paper, and as the ground shakes, it picks up these shakings, and we can use that information. There are 3 types of seismic waves. The first ones are the primary waves, or P waves. These arrive first. Okay, so the first little blips are the first waves. After that are secondary waves, or S waves. These are slower, and so they will arrive second. The third wave, and the slowest of all, are the surface waves. Okay, there's lots of different types of surface waves, but these are the ones that cause the motion on the ground. They cause all the shaking you feel and all the damage. So they give the biggest readings. Primary waves, or P waves, the first ones, these are the types of waves under the ground that travel backwards and forwards. Okay? They are the fastest, and they can travel through solids, liquids, or gases. So underground, through the air, or through water. Now they are very small, not going to cause any damage or really feel them at all. The secondary waves which come after that are slower. They only move through the ground, through solids, and they'll move up and down as they go along. The third wave, or for us the most important wave, are the surface waves. They're the slowest, and these are the waves that cause the damage from an earthquake. Okay, so they will end up rolling through the ground. They can roll up and down, causing the Earth's surface to shake and move up and down, or they can go side to side. So they can cause the ground to move left and right underneath you. Okay, the reason they cause the most damage is because they are causing the foundations and the ground to do the physical movement. They are causing the rocking. And the other important thing to keep in mind is as these surface waves travel along the Earth's surface, the further away they get from the focus, they diminish or get smaller because they have less energy. In your report on section 2, you have to do 3 important things. Define the waves, like what is a seismic wave? Okay, it's that wave of energy travelling from the focus. What are the 3 types of seismic waves? Give a description and talk about the speed of each. You can also talk about how we use the seismograph and the 3 different types of waves to find the epicenter and to talk about the magnitude of the earthquake. The most important thing, especially for merit and excellence, is to link the damage of your earthquake to the waves. And this is really focusing on if the focus is deeper underground, there's less energy for the seismic waves at the surface, so there's less damage. And it's because the focus is deeper underground, the energy has to travel further to get to the top, so it runs out and there's less damage can be done. However, the shallower the focus, the shallower the earthquake, there's more energy for the seismic waves at the surface, doesn't have to travel as far, so you get more damage. So often you can get 2 earthquakes, both magnitude 7, so they release the same amount of energy, but one that's 6 kilometres down, and there's one that's 200 kilometres down. The one that's 6 kilometres down is going to cause more damage. It doesn't have as far to reach the surface. So there's more energy, and the surface waves are going to cause more damage. So always keep that in mind, linking together the damage to the amount of energy and to how shallow or deep it was underground.